So here we are with the final lecture in chapter 1 of grade 11 chemistry book. And today we will talk about theoretical yield, actual yield, and percent yield. So let's start. When we're talking about a chemical reaction, the first thing that comes to our mind is the yield of the reaction. And by yield of the reaction, we mean how much of the product would be formed as a result of that chemical reaction. Now, this includes a couple of very important things. One, the amount of reactant taken at the start of the reaction, and second, the feasibility of the reaction. So, if you think you are carrying out a reaction that is very much feasible and it will go to completion, consuming all the reactants that we have, especially the limiting reactant, and it will completely convert into products, then of course the yield of the reaction depends upon the amount of reactant taken. Or you can say that the amount of product formed will depend upon the amount of reactant taken at the start of the reaction. So this calculation of the amount of product formed or at the end the percent yield of the reaction is actually the stoichiometry that we should be concerned about. But let's first define these three terms, that is theoretical yield, actual yield, and percent yield, and then we will solve a couple of examples from your book to explain these terms. So the first term is theoretical yield. Theoretical yield, as the name indicates, is the amount of product calculated theoretically from a balanced chemical equation. So you already know which reaction you are carrying out, and you know the balanced chemical equation for that reaction. And from the molar ratios and stoichiometric calculations, you can calculate theoretically how much of the product would be expected to be formed. So this is what theoretical yield means. So you can say that theoretical yield is calculated from the balanced chemical equation. The second term is the actual yield. Actual yield is the amount of product formed actually after completion of the reaction. So it is the actual amount of product formed. The third term is the percent yield. Percent yield is the percent amount of product formed as a result, and this is calculated from the actual yield and the theoretical yield. So you have a very simple equation, that is percent yield is equal to actual yield divided by theoretical yield multiplied by 100, and this is equal to the percent yield of the product formed as a result of a chemical reaction. Now, the percent yield in some of the reactions may be equal to 100%, or in some reactions it may be less than 100%. When we have 100% yield of the reaction, it means that the reactants have completely converted into products. The reaction is very feasible and there is 100% conversion of the reactants into products. But if we have a percent yield less than 100%, and that may be true for some of the reactions, there may be some reasons for that. One, that the reaction does not lead solely to the products that are expected as a result of that reaction, which means that there might be the formation of some side products, or you can say that some of the products formed as a result have converted back into reactants, that is reversibility. So some of the reactions may be reversible and that converts the products back into reactants, and then there might be loss of the products during handling, during performing certain step. So that is what we call experimental loss, or you can say it's a mechanical loss. And this loss happens during execution of different steps involved in the course of the experiment, like for example, you are filtering your product, you're doing extraction, you're doing distillation, or you are doing chromatographic separation, washing, etc., recrystallization. So all these steps may lead to the loss of the product to some extent, and that is what reduces the overall yield of the reaction from 100%. So we have discussed three terms today: theoretical yield, that is the yield of the product calculated from the balanced chemical equation; the actual yield, that is the actual amount of products formed as a result of the chemical reaction; and then the percent yield, that is a ratio of the actual yield and the theoretical yield multiplied by 100. And for every chemical reaction, you should write a percent yield of that reaction that shows the feasibility of that reaction, or it tells how much of the reactant actually converts into the products. So let's solve a couple of examples related to this topic. So the first example is example 1.9, and it states that in an industry, copper metal was prepared by the following reaction: zinc plus copper sulfate leading to zinc sulfate plus copper. 1.274 grams of copper sulfate when reacted with excess of zinc metal, a yield of 0.392 grams of copper metal is obtained. Calculate the percentage yield. So we are given chemical reaction between zinc and copper sulfate, and we are given the amount of product, that is copper, formed as a result. We are asked to calculate the percent yield. So what we are given is the amount of reactant, that is 1.274 grams of copper sulfate, and we are also given the amount of product, that is of copper, 0.392 grams. So 0.392 grams of copper is the actual yield of the reaction, and you know that percentage yield can be calculated from actual yield as well as the theoretical yield. So we have the actual yield, we have to calculate the theoretical yield first and then calculate the percent yield. So let's write down the balanced chemical equation first. That is zinc plus copper sulfate leading to zinc sulfate plus copper. So this is an already balanced chemical equation. The given data is the amount of copper sulfate, that is equal to 1.274 grams, and this leads to the formation of copper, which is equal to 0.392 grams, and we are asked to calculate the percentage yield. So you already know that the percent yield is equal to actual yield divided by theoretical yield multiplied by 100. So what is the actual yield? The actual yield given to us is 0.392 grams of copper. So we have to actually calculate the percentage yield of copper. And then we do not have the theoretical yield, and that is what we have to calculate from the balanced chemical equation. So let's do it. So from the balanced chemical equation, we know that because zinc is the excess reagent, we have to do the calculations with the amount of copper sulfate, that is the limiting reactant. So from the balanced chemical equation, we know that 1 mole of copper sulfate produces 1 mole of copper. That is what we have from the balanced chemical equation. Now, how many moles of copper sulfate are given? So moles of copper sulfate given are not yet calculated. So we have to calculate it. So moles is equal to the mass in grams that is given to us. You already know that. That is 1.274 grams divided by the molar mass. So you can calculate the molar mass of copper sulfate from the atomic masses of copper, sulfur, and oxygen, and it comes out to be around 159.5. So when you do the calculations, this is equal to 0.00798 moles. Or you can write it in this form as well. If you shift the decimal point here, then it is 7.98 into 10 raised to the power minus 3 moles of copper sulfate. So if 1 mole of copper sulfate produces 1 mole of copper, 7.98 into 10 raised to the power minus 3 moles of copper sulfate will produce 7.98 into 10 raised to the power minus 3 moles of copper. So what is the amount in grams of copper produced as a result? So the mass in grams produced is equal to the number of moles, that is 7.98 into 10 raised to the power minus 3, multiplied by the atomic mass of copper, that is 63.5, and this is equal to 0.5072 grams of copper. Now, this 0.5072 is the theoretical yield of copper, because from balanced chemical equation we know that 1 mole of copper sulfate will produce 1 mole of copper. So if we have 7.98 in 10 to the power 3 moles of copper sulfate, we should expect the formation of 7.98 into 10 to the power minus 3 moles of copper, and that is equal to 0.5072 grams of copper. Now this is the theoretical yield. We already know the actual yield, that is 0.392 grams, and now we have the theoretical yield, that is 0.5072 grams. Let's calculate the percent yield. So the percent yield of copper produced as a result of this chemical reaction is equal to the actual yield that is given in the question, that is 0.392 divided by the theoretical yield, that is we just calculated 0.5072 multiplied by 100, and this is equal to 77.28%. So as a result of this chemical reaction between zinc and copper sulfate, the overall amount of copper produced is 77% of what we expect to be formed as a result of the balanced chemical equation. Next is example 1.10, and the question states that in a reaction 2 moles of methane were reacted with an excess of chlorine. As a result, 177.0 grams of CCl4, that is carbon tetrachloride, is obtained. What is the A theoretical yield, B actual yield, and C percent yield of the reaction? So we are given a reaction between methane and chlorine. Let's write down a balanced chemical equation for that. So we have methane and chlorine reacting together to form CCl4 along with the formation of HCl. This reaction is the chlorination of methane. It happens through a free radical mechanism, and it happens usually in the presence of light. So let's see how many atoms of each of the elements are present. We have one carbon here on the left hand side, and we have one carbon on the right hand side. We have 4 hydrogens on the left hand side, and we only have one hydrogen on the right. So you can multiply this with 4, and that makes it 4 hydrogens. But now we have 4 chlorines plus 4 chlorines here. So we have a total of 8 chlorines on the right hand side, and here we only have 2 chlorines, so you can multiply this with 4 as well, which means that one molecule of CH4 will react with 4 molecules of chlorine to produce 1 molecule of CCl4 and 4 molecules of HCl. Or in other words, you can say that 1 mole of methane reacts with 4 moles of chlorine to produce 1 mole of CCl4 and 4 moles of HCl. And we're asked to determine theoretical yield, actual yield, and percent yield. And if you read the question again, it says that as a result of this reaction, 177 grams of CCl4 is obtained. Now that is the actual yield. So you can write the answer to part B first, that is the actual yield. So the actual yield is how much? 177.0 grams of CCl4. Now we have to come to the first part, that is theoretical yield. And you already know that theoretical yield can be calculated from the balanced chemical equation. So from the balanced chemical equation, we know that 1 mole of methane produces how many moles of CCl4? 1 mole of CCl4. But in the question, we are given 2 moles of methane, so 2 moles of CH4 will produce obviously 2 moles of CCl4. Now 2 moles of CCl4 is equal to how many grams? So the mass in grams is equal to the number of moles, that is 2 multiplied by the molar mass. And the molar mass of CCl4 is the addition of the atomic masses of carbon and 4 chlorines, and that is equal to 154, and this is equal to 308 grams. Now this is the theoretical yield of CCl4. Now we come to the third part, that is the percent yield. So the percent yield is equal to the actual yield, that is 177.0 grams divided by the theoretical yield, that is 308 grams multiplied by 100, and this is equal to 57.5%. Now this reaction goes to completion and forms 57.5% of the product, that is CCl4 at the end. So today we have discussed what actual yield, theoretical yield, and percentage yield means. We have solved a couple of examples related to the topic. You can find some other examples as well in the literature and solve them yourself. If you find it difficult, you can share it with me. And with this, we come to the end of the first chapter in grade 11 chemistry book. We'll start the second chapter soon, but before that, we'll solve the exercise first because we have some multiple choice questions here, and then we have some questions which you are asked to answer logically and briefly. So we will do the exercise next time we meet. Till then, thank you so much. Allah Hafiz.